So now we will discuss about the domain and the range of inverse trigonometric function. So in this column we are having functions, domain and range of the trigonometric function. Inverse trigonometric function. Okay. Here we are having sine inverse, which is lies in the closed intervals -1 and +1, and axis is less than in between -1 and 1. This is domain. And what about range? Range is minus pi by 2 to theta is lies in between pi by 2 and plus pi by 2 and minus pi by 2, or the closed interval pi by 2 and minus pi by 2. Closed interval means it includes pi by 2 and minus pi by 2. Okay. So similarly we have for cos inverse of x axis again lies in between -1 and +1, or in the closed interval means we are having point -1 and 1. So it includes point -1 and 1. Okay. And theta lies it in between 0 and pi, or closed interval 0 and pi, because cos is defined for cos inverse is defined for 0 and pi. Okay, that's why it lies in between 0 and pi. So how to remember this table? So I will show you one method or one trick how to remember this theorem. Okay, this column, these values of the inverse trigonometric function. So we can see domain is in between -1 and +1, is lies in between +1 -1, and lastly in between minus infinity to plus infinity, and the theta values or the range is lies between 0 to pi or minus pi by 2 to plus pi by 2. Okay. See here, consider the axis quadrant. First quadrant we know that all about. Here first 0 to pi and plus pi by 2. Here we are having minus pi by 2. Okay. And this is first quadrant. This is second. And this third. This fourth. This fourth quadrant. So here by the column, this column, the values of domain and range, you can see that nothing is lies in the third quadrant. Minus pi by 2 means it's 0 to pi, first and second quadrant. 0 to pi means first and second. 0 pi by 2 to minus pi by 2 is 1 and 4. And 0 to pi for cos we are having 0 to pi 1 and second, first and second quadrant. So nothing is lies in between, or nothing it is in the third quadrant. So we have to leave this quadrant. Okay, just we have to consider first, second and fourth quadrant, because the values of the inverse trigonometric function lies in between 1, 2 and 4, first, second and third quadrant. Okay, now we will make group of this. Yeah, totally we are having 6 trigonometric ratio. Here we are talking about the inverse of the inverse trigonometric function. So totally we are having 6. So we will make some group so that it is easy for us to understood. Okay. So in the first group, sine inverse, take sine inverse, tan inverse and cosec inverse. Because see here, sine inverse lies in between plus pi by 2 and minus pi. Tan is lies in between plus and minus. But for sine it is closed interval. For tan it is in pi by 2 we are having plus and minus pi by 2. But it is in open interval. Why we will discuss further rules. And for cosec also we are having interval minus pi by 2 to plus pi by 2. Okay. That's why we have to make sine, tan, cosec. Right here, we are considering, we are making two groups. In the first group, we are taking sine inverse of x, tan inverse of x, and cosec inverse of x. Inverse of x. Okay. So, see here, sine inverse, we are taking minus pi by 2 to plus pi 2. Minus pi by 2 to plus pi 2 means sine is lies in 1 and 4 quadrant. Why we are having a closed interval? Because sine is defined for plus 90 plus pi by 2 and minus 90 minus pi by 2. That's why we are taking closed interval for sine inverse of x. And what about tan? Here, for tan inverse we are taking also the value is same, pi by 2 and minus pi by 2. But we are taking, this one is open interval. Here we are taking this open interval. Why? Because, see here, tan 90 is infinity, means tan 90 is not defined. And similarly, tan inverse is not defined. On plus pi by 2 and minus pi by 2. Tan is not defined. That's why we are taking open interval. Open interval means we have to take the values in between plus pi by 2 and minus pi by 2. Except we should not take the values of pi by 2 and minus pi by 2. That's why we are taking a minus pi by 2. And what about cosec? See here, for cosec we are having here for closed interval minus pi by 2 and 0 comma 0 and lastly we are having closed interval. Okay, union of 0 and closed interval. While we are taking this, you can see cosec is the inverse of 1 by sine. Okay, sine is not defined at 0. Okay, sine is defined only on the pi by 2 and minus pi by 2, but it is not defined on 0. That's why we are taking, if you are taking 1 by sine of 0, then it will not define, the value will not define. Cosec is not defined on 0. That's why we are taking pi by 2 minus pi by 2 or minus pi by 2. Okay, or we can write this interval as, here I am writing, we can write this interval as closed interval pi by 2 to plus minus pi by 2 to plus pi 2 minus of 0. We are not taking 0 values. So that's why we can write this one also. Okay. For sine, the interval is minus pi by 2 to plus pi by 2 because sine is defined for both plus and minus pi by 2. For tan, we are taking the open interval plus pi by 2 minus pi by 2 because tan is not defined on pi by 2 value. Okay. And lastly, for cosec, we are also here, cosec is the inverse of sine. Just for remember how to connect this sine, we are making two groups. First is sine inverse, tan inverse, cosec inverse. So the sine and cosec are reciprocal of each other. That's why just for remember how to remember, it make it easy. Cosec is the inverse of sine. Okay, and sine is not defined on 0. That's why we are taking closed interval of minus pi by 2 plus pi by 2 and we are taking the value minus of 0. Okay. This one is about first group. And remember one point, these all lies always together because we are having pi by 2 values. They are in between pi by 2, plus pi by 2 or minus pi by 2. All these three are lies in between plus pi by 2 and minus pi by 2. That's why they are always together. Okay. Now what about the remaining? We have made group of these three. And what are the remaining? See here, cosec inverse, cot inverse, and sec inverse are remaining functions, inverse trigonometric function. So, what about these two? Now we have to take these three groups are lies in between. These three inverse trigonometric functions are lies in between minus pi by 2 to plus pi by 2. Okay. And what about the remaining? For remaining, see here. For the remaining three, we have to make another group in which, see here, cosec inverse, cot inverse, and cosec inverse. Sorry, sec inverse. Cosec inverse is lies in between 0 and pi by 2. And here we are taking close interval. Why? Cos for cos inverse, we are taking 0 to pi by because cos is defined on 0 and pi. Okay, we know the value of cos 0 and cos pi. That's why we are taking close interval of 0 and pi. And now right, second group is here, which is lies in between. Second group is lies in between 0 and pi. Okay, 0 to pi. For second group is we have taken second group as cos inverse x, cot inverse x, and sec inverse x. These three are lies in between 0 to pi, and cos inverse is having the value close interval 0 to pi because cos is defined on 0 and pi. And what about cot? You all know that cot of x is cos x by sin x. Okay. And cos of, if you are taking values 0 and pi, sin is not defined on 0 and pi. Okay. If you are taking 0 and pi here, instead of replacing x value by 0 and pi, Sine is not defined and 0 and pi. That's why we are taking here, for cot we are taking open interval. Okay, because cos x by cot is cos x by sin x. But sin x is not defined in 0 and pi. That's why we are taking, for cot we are taking open interval of 0 and pi. Okay. And what about lastly sec? Sec inverse is here. Sec is the reciprocal of cos. Okay. And for cos we have taken 0 to pi close interval. For cot we have taken 0 to pi in red, but the interval is open here. Okay. And the lastly sec inverse. Sec inverse is, we are taking sec inverse 0 to pi by 2. For closed interval 0 to pi by 2, open interval union, open interval pi by 2 to pi. That means we can also write this one as 0 to pi minus pi by 2. We can also write this one. Means cos is sec inverse is lies in between 0 to pi, and it will not define on pi by 2. That's why we are taking minus of pi by 2. Okay, we are taking minus of this, or we can write in this way or in this way, both are same. So it is very easy if you're taking in this way. First three lies in between 0 to pi. Which one? Sin inverse of x, tan inverse of x, and sin inverse, tan inverse, and lastly cosec inverse of x. These three lies between pi by 2 to minus pi by 2 to plus pi by 2. Okay. Why we had discussed. And for the second group, cos inverse, cot inverse, sec inverse, these are lies in between 0 to pi. So you can see that nothing, and no one trigonometric ratio lies in between in the third quadrant. So we have to leave this. So remember, by making the group of this, and you have to remember this. It is very important. If you remember this, automatically you can understood remaining. Okay. So these are lies in between plus pi by 2 and minus pi by 2. That means first and fourth quadrant. And these three are lies, it means 0 to pi means 0 to pi means 1 and second, first and second quadrant. So in for some we are having closed interval, and for some functions we are having open interval. Why? Because if the function is defined on that point, then we have to take closed interval. If it is not defined on that point, we have to take open interval. That means you have to take the values in between these two point, excepting the first, the initial and the terminal point. Okay. So you have to write down, make a screenshot, or you have to write down this, and remember this. If you understood this, and if you understand, and if you remember this, how to remember this column, the chapter will be easy for you. Okay, because the solution, it is based on this. These are the range means it is the principal value branch. Principal PVB. Okay, principal value branch of this trigonometric function. If you remember this one by this trick, then it will be easy for you. The chapter will be easy for you, and it will be easy for you to solve the examples. Okay. Okay, thank you.